Hi, welcome to Cyber Secure channel. Continuing with CKS exam essentials, curriculum outline broadly divided into 6 domains is flashed on the screen. In today's video, we will start the fourth domain, which is Microservices Vulnerability, having 20% weightage as per September 2024 format. This domain covers use of appropriate pod security standards, management of Kubernetes secrets, implementation of isolation techniques such as runtime sandboxes, and implementing pod-to-pod encryption. Today, we will discuss pod security standard. The pod security standard, or PSS for short, are a set of policies designed to enforce security best practices for pods in Kubernetes. These standards define specific restrictions that are applied when creating pods, ensuring that your workloads are secure by default. For example, they can disallow privileged containers, restrict the use of specific namespaces or volumes, and even enforce the use of non-root users or read-only root file systems. Essentially, they act as a guardrail to prevent common security misconfiguration. Pod security standard comes in 3 levels, each with its own set of restrictions. The first one is the privileged. This is the most permissive level. It provides the widest possible permissions and is suitable for highly trusted workloads, like system level components. However, it's not recommended for applications because it doesn't enforce any restrictions. Baseline. The baseline level is designed to prevent non-privileged escalation while still being compatible with most applications. It's a good starting point if you are looking to improve security without breaking your existing workloads. The third is restricted. This is the most restrictive level and follows the best security practices. It's ideal for security critical application as it enforces strict policies like running containers as non-root user and use read-only root file systems. The pod security standards are applied at the namespace level. This means you can define different security levels for different namespaces, depending upon the sensitivity of the workload running in them. For example, you can enforce strict policies for a namespace running critical application and more relaxed policies for development or testing environment. Now, let's look at an example of how to enforce the restricted policy in a namespace. Suppose you have a namespace called app1, which you want to enforce the restricted standard. You can do this by adding a label to the namespace definition as shown on the screen. Once this label is applied, any pod created in the app1 namespace must comply with the restricted policy. If a pod violates this policy, for example, by trying to run as a root, it will be rejected by Kubernetes. Now let's create a pod in the namespace app1 and check whether it can be created or not. As you can see, the pod creation is forbidden and reason for the non-creation is also displayed. Let us implement all the security features that needs to be implemented while creating a pod in the namespace having restricted pod security standard. It includes disallowing privilege escalation, disallowing running as a root, dropping all the capabilities, and implementing a seccom profile. Now, let us implement all these security features. Starting from a privilege escalation, then disallowing running as root, dropping all the capabilities. And in the end, implementing a seccomp profile. As we can see, when all the security features are applied, ultimately we are able to create a pod in the specified namespace. To wrap up, the key points to remember about pod security standards are they define security policies for pods at the namespace level. There are 3 levels: privileged, baseline, and restricted. The restricted level is the most secure and recommended for critical workloads. You can enforce these standards using labels in your namespace definitions. Pod security standards are a powerful tool for securing your Kubernetes workload. By implementing them, you can ensure that your applications are running in a secure and compliant environment. Thanks for watching, and I'll see you in the next session.